You ever stop and think about what's really making your favorite video games pop? Or how creative software crunches through those massive files? Well, a lot of the time, the secret ingredient is C++. And today, we're going to pull back the curtain on this powerhouse language, the invisible engine that runs so much of our digital world.
Okay, so let's kick things off with a classic problem, a real dilemma that every programmer faces. It's this constant tug-of-war between power and speed. Do you pick the language with all the fancy, high-level features that make life easy? Or do you go for the one that's just pure, raw, down-to-the-metal speed?
So picture this. It's 1979. A computer scientist named Bjarne Stroustrup is facing this exact problem. He was using a language called Simula, which was fantastic for organizing big, complicated ideas. The only problem? It was painfully slow. On the flip side, you had languages like BCPL, unbelievably fast, but way too simplistic for building massive programs. Stroustrup wanted it all. He wanted the elegance and the speed.
So what did he do? Did he start from scratch? Nope. He did something much smarter. He decided to build on a language that was already a legend, the C programming language. C was already known for being fast, portable, and pretty much everywhere. It was the perfect foundation.
His whole project was about taking the raw horsepower of C and fusing it with those smart, high-level features from Simula, specifically the idea of classes. And what he created was this new hybrid language with a very descriptive working title, C with classes.
Right, so by 1983, C with classes was getting pretty serious, and let's be honest, it needed a better name. The name they landed on was C++. It's actually a super clever little programmer joke. In C, the ++ operator means increment or add 1 to this. So C++, it's literally the next step up from C. Brilliant, right?
Now this right here is the secret sauce. The entire philosophy of C++ boils down to this one powerful idea: zero overhead abstraction. Just think of it like this. C++ gives you a ton of amazing, high-level tools, but you only pay the performance cost for the ones you actually use. If you don't use a feature, it costs you absolutely nothing. No bloat, no slowdowns.
And that whole philosophy is built on these core principles. It's all about giving the programmer the keys to the car, total manual control. It promises that the stuff you build can be just as fast as the stuff that's built in. And crucially, there's no hidden magic going on. You're as close to the hardware as you can get, which means pure, unadulterated performance. But C++ didn't just stay one person's project. It grew up. It became a global standard managed by the International Organization for Standardization, ISO. And that's when it really took off.
Just take a quick look at its journey. After it was first sold in '85, it took a while, but it got its first big official standard in 1998. But the real party started in 2011. That update, C++ 11, was a massive deal. It completely changed the game and kicked off the era of what we now call modern C++.
And get this, since 2012, C++ has been on this super regular 3-year update cycle. So we got C++ 14, 17, 20, 23. It's this constant rhythm of improvement. It means the language is always adapting, always staying fresh. This is not some dusty old relic. It's a living, breathing language.
So, after all that, where is C++ actually used today? Well, the short answer is anywhere that speed is king. If performance is the #1 thing you care about, there's a really good chance C++ is behind the scenes.
I mean, just think about the most demanding software you use. Powerhouse programs like Adobe Photoshop or the 3D animation tool Blender, the reason they can handle all those complex calculations and manipulate huge amounts of data in the blink of an eye, that's the raw power of C++.
It's also one of the pillars of the internet. Big chunks of web browsers like Firefox and the high-performance databases like MySQL that power massive websites, yep, that's C++ doing the heavy lifting to make sure everything runs smoothly for millions of people at once.
And then, of course, there's video games. In the gaming world, C++ is the undisputed champion. Why? Because it lets developers get right down to the metal, controlling the hardware and memory directly. That's how they squeeze every last drop of performance out of a system for those mind-blowing graphics and silky smooth frame rates in engines like Unreal or iconic games like World of Warcraft.
But it's not all fun and games. C++ is also trusted for the systems that absolutely, positively cannot fail. We're talking about the huge server farms that run the cloud, the telephone switches connecting our calls, and even space probes exploring the far reaches of our solar system.
It's the silent, ultra-reliable engine that just works.
So with all these shiny new languages popping up all the time, you gotta wonder, is C++ still relevant after more than 40 years? The answer is a huge, resounding yes, and the numbers don't lie. Just look at the TOBE index. It's basically the Billboard charts for programming languages. As of November 2024, C++ is ranked number 2. Not in a niche category. Number 2, in the entire world. That alone tells you how important it still is.
And here's what's even crazier. It's not just hanging on, it's actually climbing. It recently overtook Java in popularity, which is a massive deal in the tech world. It just goes to show that this language has some serious staying power.
And that's because C++ is not sitting still. There's a whole global committee that's actively developing it, planning a roadmap of new features for years to come. I mean, they're already working on the next standard, C++ 26. This thing is very much alive and kicking.
And that kind of leaves us with one final big question. As our world gets hungrier and hungrier for performance, with AI, virtual reality, you name it, is a language that gives programmers total manual control over the machine, is that an old idea? Or is it maybe more important now than ever before?